Okay, so those are the topics we got for today. So we'll get the homework area type worksheet up and running first. That is this one here. Yeah, so I'll get that worked out. Yeah, did anyone have time to work on it yet? You did? You got it started? Finished? Sure. You got those ones? Yeah. Oh, that's good. Perfect. 1, 5, 6, 7, 8. That's what we'll take a look at. And yeah, I'll leave the other ones for you. Class, are you going to be able to see this? No. It's too small, right? Too small for you? Okay. We'll put the K in quality. Try and make it better there. Like that. Zoom, it looks good for you, right? I think it always looks good for Zoom.
Yeah, it's not good.
How about that? That'll be okay? All right.
Yeah, okay.
Okay, so the first one is number 1 there then, right? That's the first one I gave you? Perfect. Number 1 it is. What are you looking at? What is the distance around? Okay. There are a couple of different orders, a couple of ways to do this. And yeah, if I understand correctly, that's one of them there. Okay. It is asking for the distance around. So what's the professional word for that description there? Not bad. I heard length plus width times 2. So that's not, I'm looking for actual word there, but yeah, we can keep that for later.
It's area, length times width.
Length times
Perimeter.
width. Yeah, both from class. That is area if you do length times the width there. Now, and so it's asking for the distance around.
And perimeter.
Yeah, the
two
other
length,
word.
plus two width.
Yep. Okay. Distance around is referring to the perimeter. Okay. So there's a couple of ways to do that from Zoom and kind of from class. From Zoom, we got this 2 times the length plus 2 times Hadil said the width, which is right like that. So you can put it as 2W.
Yeah.
Yeah. Do it simple. Don't be afraid of putting some English in there. As I said the other day, it's a good idea. It can help. Or the language of your choice, as we're international school. So this is one way that you can find the distance around the perimeter. The other way is just a slightly different order. Right? It was this answer over here. What you can do, watch this. There's a 2 and a 2 over there. The 2 is like a GCF. So you can actually rewrite the perimeter formula so that it's 2 times length plus the width. Importantly, when we're talking about a rectangle that you see up there. Okay. Square as well, kind of a special situation. But other shapes are pretty different, right? So keep in mind, this is for the rectangle. Okay, so that gives an outline of what to do. Now we have to do it, either this version or that version, this style or that style. Now we have to do it with what we got. So in the question there, what does it say about the the length and the width. What does it say about the L and the, am I going to lose my writing? I'll put it back. You help me out while I get this done. The length there, what is that going to equal? Well, you can try and write your way through the words. That's probably not too tough, actually. Right? It tells you straight up. What's the length going to be? Yeah. 3x squared plus 6x minus 10, right? Given in the phrase, given in the sentence, as well as on the picture there. The width, that's the other thing we need. What is that? Wow, perfect there. 3x plus 5. Yeah. So we have a choice now between which style to use. We got the first one here or the second one. To me, it doesn't matter a whole lot, although I think probably use that one. I think this is the one I showed in class. Yeah, but if you want to try this way, you could go for it and you should get the same answer, of course. Can you make this this smaller? Yeah. Yeah, that's what I was saying. This one here. That's the one I gave in class. This is an update, which is true. So I'm going to use number 1 just because. And I'm going to do number 1 on a separate page so that it looks good. So I'm going to start with the formula always. Shows what the thinking is, what the strategy is, and then we work it out. Using, actually, before we do, what skills are we going to have to use in order to figure this out? Of the different topics that we've gone over, what's one skill we're going to have to use in order to work this out? We're going to use this version here, use this equation, along with these values. All right, so we've gone over a few different topics, exponents, radicals, all that stuff, right? Which topics can we use for this type of question? Keeping it secret? Okay, we'll come back to it. You can tell me after. So we're going for the perimeter. Perimeter is 2L plus 2W. The length from the other page, that's going to go in for L. And that was 3x squared plus 6x minus 10. And the width is going to be there as well. 3x plus 5 like that. Perfect. So skill number 1. What are we going to do in order to simplify this? Oh, now you're telling me. Absolutely. We're going to do some multiplying with polynomials. Yep. Nice. The 2 gets multiplied in, right? Each of those along the way. This one as well. So we do that. Yeah, 6x to the 2 plus 12x minus 20, not bad. And the next one there? Plus 6x, yeah. Plus 10. Indeedio. Hideo, you okay with that?
Yeah.
Nice, okay. So now I got to use another skill. Yeah, combine the numbers that are the same. Collect like terms, right? Combine numbers, same. Yeah. These ones will go together from class, that's true. Yep. Those will be 18x. Minus 20 plus 10. Oh yeah, what's this gonna be? Okay, no. Yeah. That's good. That's right. And the 6x squared up there. That comes down. Okay, so anything else? No. Put the P there. And maybe perimeter is 6x squared plus 18x minus 10. That gets to be a bit much. This to me says the perimeter is. Okay, but just so you can see. All right, so any questions about that one? No? Who got it right before this? No? Oh, what happened? Where things go? Gotcha. From class, found area instead of perimeter. So for the distance around. Okay, so that's one thing to watch for. Something else? 5 times 2 is 10, right? So watch those sort of things as well. Not 52 and stuff like that, especially under the pressure of a test. Keep cool. Yeah, good. Okay, so that was number 1. What was the next one? 5? Okay. Number 5 then. Beautiful. Stop the screen a little bit. I'll make this big and then I'll shrink it down and do the writing. So take a look at number 5. Actually, what I'll do is we can make this work. Okay. So you help me out. What's this question asking? And what did they tell us? Oh, yeah? Okay. Square is that. That is that. Find the, okay. Now, with a lot of these questions, one sentence, one idea. All right. So in that first sentence, what information, what's it telling us there? Yep. Nice. So look along the way, we got it. There's a lot of English in that paragraph there, right? A lot of words. So what we're going to do step by step, just start translating into math. Just like English to French, right? Switching how the meaning will be there, but we're just going to write it a little different. Area square, okay? Sounds like a caveman a little bit, but I think we know what that is. Equals is translating. Then what is it? The information, 4x squared plus 4x plus 1. Perfect. Okay. The next line, what's the info given there? Area. Yeah, the rectangle there. Nice. That's true. They give the value, not the value, but the expression. Fantastic. Perfect. So that's there. And now we got to find the shaded region, which you can see on the screen over there, down there on the left. Okay. Well, good people, what's the idea? What are we going to do? How are we going to do this? If you can, think back to not yesterday, 2 days ago. That one there? Okay. Oh, perfect. So yeah, some good thoughts. So just like an English essay, you can write the stuff down. So one word that came up, minus. Perfect. We will be subtracting, right? Another related idea, yeah, put some brackets in there. I didn't put them around the first ones yesterday, but for this I will. Put the brackets in to show the subtraction. And then they even went one step further and said, put the minus in. Right? Do that. Very, very useful. You see, and still at the idea stage. So let's work this out and see what we can get. Actually, what I'm going to do is I'm going to change the writing, this writing size. So I'll do that. Do that. And then we should be good to go. Bye-bye. What do we call the area we're looking for? Shaded region, is that what they say? Okay. Shaded region is, and then using what Parsa said, area square minus area, I'm just gonna say RET. Well, I'll say rectang. That's all I can fit in there. So to help it, so we got the minus now, right? We got this area represents the full square, the whole thing. I actually should make a picture like that. This area is like the whole thing. This is the rectangle that's inside, like that, and whoop, it's gone. It's out. Yeah. So we got the region that's left. We'll just call that A for the area we want. Area of the square, 4x squared plus 4x plus 1. Minus now. This is where the brackets are important from the other day. Like that. And as was said at the idea stage, we got the brackets in place. Now we put the minus through the other terms there. And so some of you picked up on a way to do it. What I said was put a -1 in front and then just multiply it through as usual. Someone I think said you just switch the signs. Also true. Okay. So for the for here, we're going to subtract a positive, so that turns into a negative. When you subtract a negative, it turns into a positive. And when you subtract a positive, that's like subtracting now. No brackets, all gone. The other ones, that is the other terms, they're still there. Right on, right on. So of the skills that we got, what are we going to do now? Sure, combine, collect, whichever one you like. As long as you, yeah, careful when you do it. It is. It will be 3x squared for the x squared terms. That's true. Remember, you can do the different underlines if you want. Yeah, those ones will give you 9. 4 in one part, 5 in the other. Nice. Class is like getting down to work. Let's get this done. 1 minus 6. Okay, you're up one stair, then you go down by 6. So you're starting to go into the basement, right? Starting to go underground. Where you end up, 5 steps under. True and, yeah, true and correct. This is the area that's left over. This is the area of the, what do we call it? Shaded region. Good times? Okay. That's there. What was next? Number 6. Let's see. Maybe I should leave it for you. I don't know. Let's see what we got here. Number 6 looks like that, huh? Tell you what, I think let's work on this up to the idea part. Then I think I might leave the rest for you to do. Okay. And even for the next week, we can do the next couple questions, but only up to the idea part then. Leave the algebra for you to practice. Okay, so number 6 there. What info are we given?
For this question, we need to times each square, each circle, the area to 2 because we have 2 circles.
Oh, not bad.
Then we subtract like what's the name of this? Yeah,
Rectangle.
rectangle each.
Subtract rectangle minus those. Yeah, that's the idea is there, right? What is the area? That's which area is that? Yeah. Wow, x4, eh? It's getting up there. Notice it skipped an x3, x to the 3. That can happen. It's life. Just doesn't fit this situation, so it's not there. Yeah, rectangle. Yeah. Math class and elocution class. It's okay. Should hear me say rectangle in Arabic. It doesn't, I don't even know what it is. It's easier for you. All right. Okay, area of the rectangle is that. What else? I'm going to highlight this. And maybe you should as well. Because if you write down circle, your brain might, yeah, I mean, circle means one. But in the chaos of math, oh, it might put both together for some reason. So I'm just going to highlight that it's one circle only. All right. And it's, yeah, given there, x squared minus 2. I'm doing all this more for teacher stuff. If you want to write it as area rec, one circ, you know, some sort of shorthand, go right ahead. This isn't horrible anyways, but you know, you can do that. So now what's the big idea? Okay, we can go 2 times x squared minus 2. What is this going to, what is this going to do? Why are you doing this? Yeah. Yeah, perfect. That's exactly what it is. If one circle is this, area-wise, I could put area one circle. Then this would be the area of 2 circles, right? Yeah, remaining area. Okay, I'll just call it, I'll put area is important. So put remaining area. And the idea for then, for this then is to do what? Yeah, you could multiply this in. I would squeeze that over there. 2x squared minus 2 is 2x squared minus 4. That's true. We can, oh, off the screen, eh? Let's do it like this. So we're starting to talk about the idea now, right? How to get these pieces together. This showed multiply by 2 to get the area of 2 circles. And then this is what you get when you actually do it. Multiply that 2 through. Perfect. What now then for the, to get us closer? We got that over there, yeah. Snuck that in there while you're busy writing. So yeah, we got that there. Okay, we'll combine these for sure because they're related to one another, right? How are we going to combine them though? This is the area of the rectangle, so the full thing it's the area of, oh, that's one circle. two circles. All right, so how do those shapes all relate to one another? What can we do? No. Imagine that this sheet was actually the rectangle. And then two circles are gone, right? You cut them out. So what would be the math idea to show that? Yeah, minus, exactly. You have the full area. And what you're doing is you're taking away this circle, taking away that circle, right? So what you're doing is you got using the words there. Area the rectangle. And I'll use take away, and we can update that to math in a bit. Take away the two circles. Zoom, you can see this okay?
Yeah.
Okay, it's starting to get a little fuzzy in class. Okay, so let's translate this now into math with some of the facts that we have on this page here. Okay, see what we can do. Clean it up a bit. It's getting a bit busy, right? Look at this, a lot of green. Not a bad color, but let's make it look good. So you help me out. Remaining area is what we're going for. So I'm just going to write A for that. Or no, I'll do A in the next step, just for teaching purposes. Remaining area is, what's the area of this rectangle, the whole thing?
5x4
Exactly.
plus 3x2 minus 6 plus 8.
Yep. Yeah. The whole area, whole
And
expression for sure. Yeah.
so we can do minus 2 circle, that's x2 minus 4.
Yeah, nice. So Zoom kind of got it. Zoom said minus 2x squared minus 4, but the brackets are important. Otherwise, algebra disaster.
Hmm.
Okay. It won't work then. So a couple steps to go. Wait a second. What am I doing this? I think I was going to stop at the area and I forgot, you luckies.
So multiply the minus.
Yeah, the minus goes in. What happens? Yeah, the signs switch. Different switch. Oh, that's why I didn't do it this way, because of the switch word. Switch is for exponents. Not officially, but just for class, right? So maybe think of it. Well, you know what? You think of it so you're successful. That's the way to do it. Okay. Invisible one, multiply it through, or change the signs that are there. These ones all remain.
So now we can make the adding together.
Yeah, add whatever is possible, combine whatever is possible.
Combine. Yeah.
Yeah, so we'll get the area here at the end is equal to, 5x to the 4 is going to come down. It'll be a 2x, like. Yeah, exactly. That's what those x squareds end up being. Yeah. How about the x's? Yeah. There's only one location, stays the same. Yep. Perfect.
uh, uh,
Ta-da, there it is. Snuck it out of me. So tell you what, why don't we leave it there then? I know there's some other questions. Yeah? What do you think? You a little more prepared for the other ones now? Yeah, you can try it on the weekends, I think. Okay. Hand this in by the end of class if you can. If not, then on Monday, okay?
okay.
Yeah.
Yeah.
Okay. Okay, so that was 6 that you snuck out of me. 7. Yeah, 7 looks pretty ordinary. The width is there. Oh, we could, you know what? We can set up number 8. How about that? Just so you can get started with the correct, in the correct direction there. Number 7, it's wordy, but I think you guys you should work through that one. Number 8, though. That's the whole thing there. Right at the bottom. So good people, what info are we getting? Whoops. Ah, there, that's good. Perfect. Is that all it says? No, can't be. The second. Yeah, okay. Well, number 8, the width is there. So how can we write that down?
So we need to find the legs.
Yeah, I think class got it. Zoom width equals x minus 5. As a little update, w equals x minus 5. The width, yeah, for sure.
Um,
And the L is 4W.
Nice. So translating looking at the length now, right? It says length is 4 times the width. 4 times width.
Nothing is changed.
Well, that's no good.
will be x minus 25. I know.
Well, we have this idea from the second sentence, right? So we can work vertically and get it translated. Length is not bad. Class said 4 bracket
Yeah,
W.
I think.
Okay. True, but you don't really need the brackets for this situation. This would be okay.
If you want put brackets, you need to like write the W, x minus 5.
Yeah, well, so a couple things. To translate it directly, length, L, is equals 4 times the width, right? So yeah, you don't really need the brackets, but you can if you want. But yeah, as class is now saying,
So x minus 20. I know.
yeah, exactly. Zoom is given the answer and you're saying, class is saying what to do. So now what we can do, the length is 4 times, what's the width?
So
Exactly, x minus 5. And so the update is there. Yeah, exactly. Length is 4x minus 20. So as I said, I'm leaving it. And you guys work through it. Don't want to do the accident of working through. But what do we have? Width is x minus 5. Length is 4x minus 20. What's not mentioned is the shape. It just says Buddy's room, Adrian's room there, right?
But because we have length and like width is like it's going to be I don't know how to say that, but what did you say this in English?
This one?
No, no, no. No, 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 no. When something is like
Okay. When things are the same distance apart from one another, like railroad tracks, they are parallel to one another.
okay, yeah.
Okay.
Because of this thing, it's going to be rectangle.
Yeah,
Or the
that's true. So Rhombus, a weird shape, but we'll keep it like this.
yeah.
Okay, we're going to assume if it doesn't say, I look at my classroom, right? You're at home, look at your kitchen. What's the shape? Pretty much a rectangle, right? So that's what we'll use in order to finish off this this particular question. Okay. Actually, what we'll do, because we have a few people away, a few people to catch up, what we'll do is I'll give you guys 9 minutes to do those questions 7 and 8. You work on them on your own right now, okay? I'll pause the video and we can check those over today. That would make more sense than leaving it till a little bit later. So pausing the video, a bit of time to finish 7 and 8. We'll check them and then move on forward with our mathematical lives. Yeah, okay, so taking a look at number 7. First thing is, yeah, the circular plot of land has that area. So what do we say? Land is yeah, 7x to the 5 minus x to the 3 plus 4x squared plus 9, right? That's true. What else is there? Walkway. Yeah. Minus 4x to the 3 plus 2x. Okay, so I guess just to have some shapes, like this is the inside, right? 2x, yeah. 2x. And then this one is the walkway. So I'll shade it in. That's that area, right? Now, what are they asking for? Because am I adding or subtracting? I don't know yet. Oh, so they actually say combined for this question. That's the last question. Yeah, we're looking at number 7 first, the donut that's there. 7 before 8. We'll do it that way. It works. So yeah, combined, as I said, sometimes it's add, sometimes it's subtract. What is it in this case? No, I know. But the question is combine how? We're going to be adding or subtracting for this situation. Yeah, it is. Yeah. For this one from class, we got adding, and that's exactly. Yep, subtracting means minus. Okay, I'll show that up. show that up? I'll show that here. Add, plus, like that. Subtract, minus, like that. Times, multiply. Like that. And we got divide. And sometimes it's 3/2, 10/2. Okay, so that's divide. And there's a gazillion ways to show times, brackets and that sort of thing.
I did my working on different pieces of paper.
That means you get it. That means you get an A, paperclip. Okay, that's okay. Camera's here. They're there. So yeah, we're gonna add these ones though, these expressions now to get the result for this, right? So yeah, I'm writing combined, maybe area instead. A is equal to, maybe just try it like this so I can save some real estate here. What do we get through to the answer? Mm-hmm. Those ones. That's true. So we're going to save that till a little later on, just so it's all written out in order. That's -5, so we'll save that. That's true. What else? Oh, that's it. Yeah. It's the only one, right? X to the 5, to the 4, to the 3 we got, to the 2, to the 1. Officially to the 0, but number on its own. Yeah, good. So final answer? -5. Oh, you know what? Let's try and keep it in order. Did I miss it? 7x5. Yeah, plus x4. Did you say that? Did I miss it? Plus x4, x to the 4. Minus 5x to the 3, yes. Yeah, a little messy, but 2x plus 9. That does that there. Very true. Okay, number 7. Good, done. Number 8. That was the one with 4 times and all that in there. What's that going to look like? Oh, it's still up. Well, it certainly got it started. Width is x minus 5. Length was, we got as far as 4x minus 20. Okay, so I'll pick it up from there. Well, this is the question. What are we going to do? So if we're looking for the area, then yes, that would be length times width. If we're looking for a perimeter, we're going to do the other one. So what is this question asking? Perimeter. Says it right there. See? So why did you do that? You're going to be multiplying by 2 in there because you got to get, you see the width and the length. That's like the width and then the length. Watch in the picture. Girls, watch on the picture here. The width is there. Length is there. You need the other part as well. So you got to go all the way around. Remember, you're like the mosquito. You're starting here. Exactly, because you get a width also on this side going the other direction, and a length on that side going in the other direction. So yes, That's where those 2's come from. And the two different ways. You can add them together, multiply by 2, or use the formula that I showed you in class, right? Either one. Which one would you like to use? Well, good. I'm glad you want to use the perimeter one. You want to use this one or add in times 2? So the other one's like this instead. You add the length and the width, and then you multiply by 2. You see? Which one? This one? Okay. So 2 times the length. Keep the order, just so it's when I see length. Oh yeah, it's 4x minus 20. Let me see width. X minus 5. We might have to pay attention to some brackets later on, but this is okay for now. What? Someone's telling me lies. So you could start multiplying this out, or you can simplify the inside first. It's up to you. Okay. I think someone's enthusiastically doing the multiplying, so we'll do that. 2 times 4 is what though? And this classroom is going to be 8. 2 times 20. Yeah, it's true. Honestly, I think working the inside first is better. This is true, but not so sure about. Yeah, plus 2x minus 10. You see, now we got to work with big numbers as opposed to small numbers. Instead of 20, I got to deal with 40. Instead of 5, I got to deal with 10. Now what do I do? It's Friday afternoon. Brain doesn't work that well. Okay, so be careful. You got to get it right. What final answer? I don't know. There we go. That's why we made it. Yeah. What do we got for the x's, good people? 10x. Yeah, indeed. And the other one?
minus 30.
Ah, so zoom, be careful there. No, it is minus. Yeah. You're down
Yeah.
40, then you're down another 10.
Oh, 50.
Yeah.
Okay.
Perimeter is at 10x minus 50. Yeah. Okay. Very good. So what do we got now? Question on the board that's pretty fancy looking. I'll take a look at that later on. I'm gonna, I know, there's a famous mathematician that ran out of space too. Kept people busy for 350 years until they solved the problem. It's true. I'm going to show you what's coming next. And if you like it, you can get started on it. The other people can get caught up. What we're looking at is, as I said, Friday afternoon, just giving you the information today. Next day, we'll talk a little bit about it and make it a little more user-friendly. Yeah. So we're taking a look at something called the slope of a line. That's what you can see is how steep a line is. Lines are a big deal in math-related worlds. Finance, physics, even chemistry. You saw the chemistry in math, right? With enthusiasm? With enthusiasm. Yeah. Yeah, exactly. So lines are, yeah, very useful for helping helping out with different types of calculations, creating different types of equations. Shorthand for equations. at least in this class. Okay. So we're going to talk a little bit more about this next day, the hows and whys. But so for today, let's get you started here. All right, the slope of a line at the very basic for us here in math is how steep a line is. The measure for how steep it is. So if it goes up very fast versus like this, right? This line is considered steep, and this line is like shallow. This line here will have a big slope. Let's say like 12. And then this shallow one will have a low slope. And it might be something like 1/3, 2/3, some sort of fraction. You know, it's going to depend on the situation, but roughly that's what's happening there. A bigger number shows you it gets taller faster. To get these numbers, this is what we're going to focus on for next little bit, is this equation here. This equation helps get the number, helps get the 12, helps get the 1/3. You gotta figure out you gotta know what those x1, y1, x2, y2 are. Has everyone seen those symbols before? Yeah? Okay. Nice. Right. If you have 2 points, and they're probably going to be on a graph. If you call this point number 1, you can call that point number 2. It might be the other way around. Officially, it doesn't really matter. This point has a location on the graph. We say if it goes to the right or to the left. And then we also say if it goes up or if it goes down from the origin there. So for the right and left direction, that's the x direction. And that will be given by the x-axis that's located there. X-axis goes this way. When it's right, x values are positive. And when it's left, x values are negative, as you will see. If we're going up and down, this is in the y direction. So that's the y-axis. Okay, if we go up, it's positive. Go down, it's minus. Yeah, negative. We got it. And I'll show you this in a couple slides. Okay, so what's going to happen is point 1, it's going to have a left and right number. So there'll be an x there for the first point, so it gets a 1. And then it'll show whether it's up or down. That'll be the y value. And since it's 0.1, it's 1 there again. Right?
Like, I want to write it like this. Here, like this.
Nice. From class, we got represented a different way. Instead of like this, they're showing it like this, x and y. I know what that is. That's something called a, or at least I call it a column vector. Kind of from yeah, kind of a different section of math. And yeah, I'm going to say try and translate it to this version, okay? So all you do is just go "Oop," tip it on its side, and then it's good to go. Okay. But if you write stuff on the board, I'll know what that is. Okay. Not on your test though. Translate it to Canadian. Right. So so yeah, x1 for the left right of 0.1, y1 for the up down of y1. Same for 0.2. X direction, left right, up down for the 0.2 there. What we can do is we can connect and imagine that there's a line connecting those two points with one another. And if we had some numbers, we could use the formula that we have there on the screen. Okay. We can do the calculating. The slope is, take the y value there and subtract the y value there. Take the x value there and subtract the x value there. That goes on the bottom. Then you just work it out. Okay. For the questions that are coming, you might have to read the point off a graph. So remember, it's left to right first and then up down. Or they might be given to you as kind of like you see here. This would be 0.1 is 2, 7. 0.2 is 8, 20. Then you go work it out. That's what's coming up. Okay, see? So if those were the numbers, substitute them in and work it out. I can even just show you that one here. We're given that 0.1, the first one there, 3, 4. So that would be x1, y1 like that. And then the other point, what we got there, 3 and -2. That's x2, y2. Substitute it in. Formula first. Anyone take physics yet? Formula first. Yeah. A shorter way of writing slope, m for some reason. S-L-O-P-E. There's no m in there. So I don't know why, but m will show up sometimes for slope. Okay, but for y2, what value do we have? -2, right? For y1, what do we got? -4. For x2, what do we got? 3. And for x1, what do we got? Oh, 3 as well. Kind of an odd example to start with, but so there it is. Okay, and so you work it out. You'll get -6 over 0. And so instead of a number like 12 or 3 or something like that, because it divides by 0, it gets a math word associated with it. It's called undefined. And as we'll see later on, this is a bit out of order. Later on, we'll see that this means that the line is actually just going straight up and down like this. It means it's a vertical line. Okay, but for now, this is just to show you where the x1, y1 are, x2, y2, and yeah, just a little sample calculation for you. So what do we got then? Yeah, because it divides by 0, the universe explodes. That's what that's showing. Oh, all that means is it's undefined. We get a vertical line. Okay, but now this is a little more realistic. Okay, everyone can understand how the graph works, how the points work? Left, right, negatives and all that? Okay, so there it is there. Anyone recognize this? Yeah, what is it?
Same thing, but there's more bigger guys.
Yeah, you connect them all together, make a line. That's true. You get a bunch of points. That's what happens. Where would you see a picture like this?
Like the
Measure,
net
Like
force of
thing?
mountain, like this.
Net force from class. Yeah, that's kind of getting.
For mountains, like
Not in algebra? It's kind of true. At least not what I'm thinking of. Zoom, what'd you say, Hadil?
No, I'm say just we see like things like that when we measure the time.
Oh, nice. The M word. When you measure.
Yeah.
Well, that's not bad. Where do you guys measure things? Yeah, you do. I'll give you a head start. Guess a letter. Remember the hint from earlier, R, S, T, L, N, and E. Remember those, the popular letters in English? R, S, T, L, N, and E. Which one would you like to guess? All right. Sure. This graph's from science class. If you
Yeah.
take a look, you got volts along this side, and you got amps along this side. So in physics, this means something, right? Okay, but what it means for us is that you get a bunch of dots from the measurements, and then really an important thing to be able to do is figure out the equation of the line that, as you said earlier, yeah, connects points, right? As many as possible, or as close to as many as possible, right? Nice. So class is saying you connect the dots and you can get the shape, right? Good. So there's actually a bunch of different shapes. And here in math class in grade 10, we're going to talk about this one. Okay. The other ones, look at it a little bit more in grade 11 and 12, right? But yeah, absolutely. They'll have their own type of equation with them then. Okay. So we're going to be, and then the line, we can use the line for those other ones. So the line is everywhere. That's why we look at it. Yeah. So measure in science class, that's where it comes up. This is from science actually more than, it's math too. You know what? The two start overlapping. So we got X as the independent variable, the one you control like in science class. That's along the, got some noise in Zoom land. We got the independent that's going to be along here. And that will be the X values. And then the dependent will be along there. And those will be the Y values. Okay. See, just shows it there. This comes up where we start looking at the equation of the line. That's an important goal for us. Okay, and for us, it means going to be finding two different numbers. as it shows in the picture here, the equation of a line has this type of equation. Y on its own equals the slope for how steep the line is, the letter X, and then B is something called the y-intercept. And the y-intercept is where the graph crosses, where the line crosses the y-axis. Okay, let's give them the name y-intercept. That's going to come in a couple of days for us. But importantly for us to get started, the slope is the number right in front of x. There's no calculating to do. Y is equal to 3x plus 7. What's the slope? 3. That's how steep the line is. Just reading it off there. So I got a bunch of graphs and just that equation there. So you see, this is a nice version of our science class, right? Just done on the computer instead. Measurements, they're not in a straight line. They're all over the place. Kind of in a straight line, right? So you draw a line as best as you can, and we can maybe try and find the equation. Find the slope, y-intercept, and that's good. Same situation. Points are kind of a straight line, pretty good. So we make our best guess and then find the slope, y-intercept. It's good. This is a situation where it comes up in business instead of science class. The amount of, if you sell something, you got money coming in. That's what revenue is. And it costs to make the things that you sell. So that's the cost. Imagine these pens, right? Cost me $1 to get one. And then I sell them for $5, right? Totally unethical, but, right? So then there's going to be a line for the money that comes in, the $5. And then the money also that that is spent to acquire it in the first place, right? $1 for one, $2 for two, 3 for 3, and so on. All these different number of markers then can create the graph, create the line that we have. And so this point here where the lines cross, that's important. That's where the costs equal the revenue. The money out equals the money in, right? So that means we don't make anything at that point. If we go further, we start making, as it shows, some profit. If we make or if we sell less, then we lose money. So the graph helps with that planning. See, another graph just with some numbers. If we wanted, if we had time, we could do it next day. Pull some numbers off, do some calculating, figure some things out. Closer look, just so we can read the numbers. And these now are just different styles of graphs and information. See, instead of markers, you got apples down here. Costs for each of them. Closer look. Physics, distance and time. Time, as I remember, is usually on the bottom, but we can flip things around. Here we got time on the bottom, money on the side, right? Just math, just to do it. And this one's different than all the rest because it goes down instead of up. So this slope would be negative once we work it out instead of positive. Goes down instead of up. So different situation. And I think good people, that will be it. Yeah? Yeah. I think there's a couple more, but we can deal with those all on Monday when everyone else is back here. Okay, example we had to begin with, dividing by 0. Whew. Shocking. Okay, so for homework, what I'm going to have you do is finish up the questions on that area. There's a few missing still. Try those ones. What was it? 2, 3, 4, maybe? From
And
the-
so day 20.
Yeah, day 20, 2, 3, 4. Finish those ones up. And then, yeah, we'll get moving next week. Really moving. Okay,
Okay.
perfect. So I'm going to stop the video and yeah, we'll see you next week, okay?